Station number 4, graphing inequalities. The last thing you need to know how to do for this test, ladies and gentlemen, is graph an inequality or a system of inequalities, depending on the problem. The first two, you just have to graph an inequality. The last two, 2a and 2b, you've got to graph both at the same time, a system. I doubt you can graph 2 if you can't graph 1. So let's make sure you can graph 1 okay. The first one, y is less than 3x minus 5. If that was y equals 3x minus 5, you'd be like, oh, slope-intercept form, what is this, a joke? I put a dot at negative 5, and then I go up 3 over 1, up 3 over 1, up 3 over 1. No, it is not a joke. You pretty much do that, but you need to be careful. If it's strictly less than, there's no less than or equal to, you need to make it a dashed line. So start at negative 5, go up 3 over 1 like you would do, but make it a dashed line when you draw it. You've got your inequality set up now. You need to shade. Pick any point you want. I always pick 0, 0 because it's easy. You can pick any point to test which way you're going to shade. It's either left or right. If you test a point and it works, you're going to shade towards that point. If you test a point and it doesn't, you shade away. So for the first one, when I plug in 0, 0 is less than 3 times 0 is 0, 0 minus 5. 0 is less than negative 5. That's what you're telling me? 0 is less than negative 5. No, that's not true. 0 is not less than negative 5. So I'm not going to shade 0, 0. I'm going to shade away from 0, 0 because that is so wrong. I want to go the other way. I'm going to shade to the right in this problem. The second one is in standard form. So find your intercepts. When you cover up y, you get 3x equals 12, so your x-intercept is 4. Put it out at 4. All right. When you cover up x, negative 6y is 12, so your y-intercept is negative 2. Put it out at negative 2. This is greater than or equal to, so it's going to be a solid line. Connect the dots. I got a line. I just need to figure out, do I shade up or down? You can't look at it and just because it says greater than, shade up. It doesn't work that way. You got to test a point. So I'll plug in 0, 0 again. It's easy. 0 minus 0 is greater than or equal to 12. 0 is bigger than 12. Really? No. 0 is not bigger than 12, so I'm going to shade away from 0, 0. I'm going to shade down in this problem, and now I'm done. For the systems, x is greater than 4. Remember back when we graphed lines, we had these weird ones where x equals 4. That's a vertical line that passes through 4. So I'm going to put a vertical dashed line through 4 because it's greater than, it's not greater than or equal to. And numbers that are greater than 4 on the number line are to the right. So I'm going to shade right on that one. That one's pretty easy. The other one is in standard form. So I'll find my x-intercept. My x-intercept is 8, so I put it out at 8. 4y equals 8, which means the y-intercept is 2, so I put it out at 2. This is less than or equal to, so it's a solid line. Go ahead and connect the dots. Got yourself a nice, pretty solid line. I need to figure out which way I'm going to shade this line. If I plug in 0, 0, 0 plus 0 is less than or equal to 8. True, 0 is less than 8. So I'm going to shade towards 0, 0. I'm going to shade down in this problem. Now I'm already shading to the right for x is greater than 4, and now I'm shading down for the second one. The overlap is really what you care about, so I'm going to go ahead and shade the overlap now, which is the bottom right corner of this graph. Last one, y is less than 1/3 x minus 2. So start at negative 2, put a dot, go up 1 over 3, up 1 over 3, up 1 over 3. That is a dashed line because it's less than. The other one, start at positive 3, go up 4 over 1, up 4 over 1. That's a solid line. I have my lines, and now I need to figure out which way to shade. For the top one, I plug in 0, 0, and I get 0 is less than 0 minus 2. 0 is not less than negative 2, so I'm going to shade down. I'm going to shade away from the origin, but I'm just going to put little arrows this time. For the bottom one, y is greater than or equal to 4x plus 3. So when I plug in 0, 0, 0 is greater than or equal to 0 plus 3. 0 is bigger than 3. No, it's not. Don't shade 0, 0. Shade away from 0, 0. That's to the left in this problem. So I'm shading to the left on one of them and down on the other. The overlap's what I care about. The overlap would be the bottom left corner here, so I'm going to go ahead and shade that. And any point that I pick in that region would work in both equations. So if you want to test it, go ahead and pick one. And you're done.